where it crosses the y-axis we call point B. All right? So if I had y equals mx plus b, if we have it in that form, there's 0b, there's my rise, there's my run. So that's a picture of what this equation is telling me. I have my slope, I have my y-intercept. If it's in that form, it's really easy to read the slope and the y-intercept. And I already saw a lot of you using this equation, this form of the line. Okay. A more general is point slope. So I have y minus y1 times or equals quantity m times x minus x1. Can somebody tell me what the y1 and the x1 stand for? Remember?
Yeah, the x and y coordinates of the first set.
Yeah, if you're given a point, we have an x coordinate and a y coordinate. We call it x1 and y1. Again, m is the slope, and that's our point. So it's a point contained on the line, and we just call the first x coordinate x1, the first y coordinate y1. All right. So it turns out that y equals mx plus b is a special case of this. Can anybody think of why? What if I have a y-intercept? What does this become? The x1, y1. If it's on the y-axis. What's 0? If I have this point, 0b, what's x1 in this case? 0, what's y1? B. So if we just take those values and plug them in, if I put in 0 for x1 and I put in b for y1, and we shuffle stuff around, we get y equals mx plus b. We'll try to get rid of this thing. So this slope-intercept is really just a specific case of a more general point-slope form. All right, so you can always start here, or you can remember this form as well. Either way is going to work. All right, so let's look at an example. So given 2 points, what is the equation of the line? All right, I want you guys to work on that for a minute, and then we'll come back together and we'll talk about it. All right, so for solving this, we have kind of two options from the beginning. We can either plug it into point slope, or we can do the y-intercept, slope-intercept. Well, is it obvious what the y-intercept is going to be with those 2 points?
No.
No, because I'm not giving them. The first thing I want to always do, I'm going to go backwards. Sorry. Why is this backwards? Okay. I had another problem here, sorry. Is I want to figure out the slope. Either way, I'm going to need the slope. So I take my difference in y values over my difference in x values. Now, do I have to do 8 minus 5? What do you think? No. I could do 5 minus 8, but once I pick a direction, I have to stick with that direction. So if I go from 8 to 5, I have to go from 3 to -1. A common mistake you're going to see is flipping those two things over, right? So once you pick a direction, you got to go through it. And now I can do is pick my points, plug them in, and I get my equation of the line. So this is a valid equation for the line. I could have also picked the other point. Is it going to be the same equation? We would hope so, right? Otherwise, you just have a 50-50 chance of getting it right. So it should work out that whatever points I pick, it's going to be the same equation. Works out that they are. All right. If I wanted to solve this one, so equation of the line is perpendicular. Here's my equation, y equals 1/4 x minus 6. That's given to me in slope-intercept form. I know the slope is 1/4, so perpendicular, I flip it and get -4/1. I plug it in, and I chose to use point slope. Plug in my points and go from there. So I want you guys to copy that down, and then what I want you to do is to show me, because we're struggling with fractions a little bit, show me that these two are actually the same thing. I should get the same equation of a line. So show me that those are going to be the same.
Should I bring this thing up?
Yeah.
Okay.
You don't have to press that.
Oh. Don't show this again. I guess. I'm just going to do +1. That's basically what that is. And 5 is 20 over 4. I'll just, okay. Then add that to 3 over 4, you get 23 over 4. Somehow erase all of this, and then...
We're going to get some practice where everybody...
Okay, so remember what the last answer was. And then... to go away. There's something on the top portion of the screen. Okay.
Alright, you good?
Yep. Plus 8. Go to 32.
Outstanding. Thank you, sir. Alright, good job. So, we're going to keep trying to use this to present. I know it's a little funky right now, but you get better at it. And what I like is that we can just record everything and go from there. So, all right. So, when we want to show that they're the same, that would be a type of question that I would give on a test or a quiz. It kind of asks you to show that they're the same because it makes you really expand on the concept. All right, here's another one. Given a point, 3, -3, and a slope of 2, determine the y-intercept. I want to go through and basically solve. So I want to get it into the slope-intercept form. I get y equals 2x minus 9. That's my y-intercept. Is there another way that we could do this? Yeah, Tom.
Could you just start with y equals 2x plus b and then you put 3 -3 at the y station?
You could start with the slope-intercept form and put those points in. Could you generate another point? You could, right? You could, if you're given a slope, at one point you can get another point with your rise and your run. So you could start with 2 points. Lots of different ways to do it. But the key is that somehow you get it into a format where you can identify the y-intercept. All right. Same thing. This is running through figuring out our slope. What I did here is I took my general slope form, right? And I plugged in the points that I know, and I plugged in the point that I wanted. B and 0. And if I solve for B, I get -9 as well. So I didn't even have to really mess with the equation. I can go straight to the slope because the slope is the difference of 2 points. So you put them in the point that you want. That would be another way to do it. Alright, looks like things are okay so far. let's talk real quick about scatter plots. And this is where I think the book, like if you look at the book, it looks like they just crammed everything they could into it, and this is one of those sections. So it's going to talk about scatter plots and correlations. And correlation is something that you'll study all over the place down the road. Correlation, this is a scatter plot. You take data and you plot it on your x and y axes and you get a range of values. All right? It'd be nice in the real world if everything was like perfectly linear, but it doesn't work that way. So we have some variation. So we have a little bit of spread between our points. So, and looking at the upper left here, we have what's called a strong positive correlation. What would be the slope of this one here in the upper left? Positive or negative? Positive. This one is negative. Why would we say that one is weak positive? Can anybody have an idea why it would be weakly positive? Yeah, just it's more spread out, right? If I was to, basically what we're going to do is we're going to try to draw a line that fits this data. This one here I have kind of lots of different lines that would work, and so we generally draw something that has less of the slope like that. Okay. All right. And then this one down here in the bottom left is no correlation. Everything is just randomly kind of distributed. So basically a correlation is a measure of how strongly related two variables are. And something to keep in mind is correlation is not equal to causation. This is a common sports broadcaster mistake. They want to attribute something being caused to something being correlated. And an example is height and weight. Okay? If we were to just get everybody's height and weight, we would expect some correlation. Which direction do you think it would be, positive or negative for my correlation if I was to plot some points for height and weight? Positive. All right, let's look at some points. If I put them up in general, people that are taller weigh more, right? With some variation in that. So we have a positive prediction. Now, the causation is different. Just because those two are related doesn't mean that weighing more makes you taller, right? True? Okay. And they talk about it, the way they say it's a sports mistake is you hear broadcasters, if you watch football or whatever, or even baseball is even worse, they talk about, you know, every fourth Sunday following a game on a Thursday, this team is an 80% win streak, right? And so you have to think of that might be correlated, but is that actually the factor that's causing them to be winning that next game? All right? This is some more correlations. So these are generated with computers. And you can see that our range of values for correlation goes from 0. 0 means there's no correlation. It's just basically random data. To 1, where 1 is almost exactly correlated. Okay? It's almost a very good predictor. They're highly related variables. So we get that range of values there. What you're going to do in the book is it's going to give you different scatter plots. You're going to plot them, and it's going to ask you to create a line of best fit. So basically, you're going to pick some points, draw the line that goes through there that seems like the best fit, and find the equation of that line. So it's a fancy way to take 2 points and figure it out. All right. So those are the two sections, equation of the line and then the correlation stuff. Questions on that before we start the